Hi. Now finally then, for this question, we're asked to show that the cost is a minimum. And there's two ways that we can do this. We can either apply the second differential method, or we can do a gradient test. And I've done both here, as you can see. If you're going to go for the second differential test, what we do is we take our equation for the cost, and I've then rewritten it as having this r to the minus 1 here, preparing it for differentiation. So in the previous part, we found out that when we had this, dc dr gave me this expression here. And then all I've done is differentiated it again with respect to r. And you can see we end up with 12 pi plus 600 pi r to the power minus 3. And writing r to the power minus 3 as 1 over r cubed gives us this. Now, from the previous part, we knew that r was 2.924 and so on. So all I need to do is substitute this into our equation here, as I've done, and it comes out as 113.09 and so on. A value which is greater than 0. And remember, if you get a positive value, it shows that we have a minimum. Okay, so in this case, C is a minimum. You could argue that since R is positive here, then this term is positive, this term will be positive, so you don't really need to work out the value. It's obviously going to be positive. The other way though is to just take the gradient. Okay, we've got a table here I've constructed. We've got the value of r, 2.924. Take a value to the left of it, below it. That can be any value. I'm going to take 1 though. Okay, take a value though that's greater than 0, because this will be undefined for r being 0. So 1 is a nice convenient value. Take a value greater than 2.924. 3 is a nice value. Substitute these values into our equation for dc dr, the gradient equation. Okay, when you substitute 1 in, you'll find you'll get a negative value. So that means the slope is downwards. We know that when r is 2.924 and so on, the gradient is 0, so that's horizontal. When you substitute 3 in to here, you get a positive value, and so the gradient of the curve is going to be coming upwards. So clearly we've got a curve for C that bottoms out like this around the point where r is 2.924. So clearly a minimum. So two ways there that you can prove that result.